Good afternoon. Welcome to EduSet Network. Friend, as you know, this week we have a discussion on very important topic, especially for the research scholars. They need to know what are the software available in the market for the analysis of data, tabulation of data, and various other like simulation and data mining. So we'll try to understand the first introductory lecture, what are the software and how can we use for our benefit. And for discussion on this topic, we have in studio very eminent personality, Dr. O.P. Wali. He teaches in Indian Institute of Foreign Trade and have long experience of this field and about the software, other managerial practices. So on your behalf, I welcome Dr. Wali for EduSet lecture on this very topic. Welcome, sir.
Thank you. Welcome to this. We have actually a series of sessions that we will be conducting now today and next 4 days, where we will talk about this domain of analytics, data analysis, and how do we use automation tools like software and other tools which help us making this whole process of data analysis much faster, efficient, and more predictable for meeting a decision requirement. So since decision is the core of decision making, or effective decision making is the core of business success, and possibly analysis would be a part of the decision making process since the time people have been taking decisions. But the breadth and the depth of analysis has definitely increased because of the advances in the information technology, computing power, and the communication advancements. So with that, gradually the kind of tools in the market have increased over a period of time, starting with something basic like spreadsheet applications, and then gradually other tools like business intelligence tools and data mining tools, statistical software tools. All these tools have spread across to help decision makers take decisions more effectively and efficiently. So this session and the sessions follow are dedicated to this kind of appreciation about these kind of tools and how they help managers and decision makers in organizations to take effective and reasonably feasible decisions in the organization. So if we look at the process of decision making, you will appreciate that if we can get into systematic process of decision making at any stage, but the earlier we do, better it is, because it helps us to plan it better, get the right data in place, and be more accurate about our results at the end of the day, because results are that really matter for a decision maker. So we have to plan it early. We should start with a elaborate plan. How do we really go about taking a decision, and how do we really analyze that data, and what kind of tools we can apply. But whatever data we get and whatever information we get is the soul of the whole decision making, because if we don't have information, if we don't have data, we possibly may not be able to just justify and address all concerns that come up when we start analyzing a particular situation. So we need to have hand on the data information that is relevant for our kind of situation and the decision we are taking. We need to clean that, because there are a lot of impurities in the data. Impurities would mean that there could be missing data, there could be data which is duplicated, there could be data which is in a very different format. So we need to really address all these things before we start using the kind of data. We will talk a bit more about that slightly later. So once we have this data which is prepared and cleaned, we need to code that data, and we need to put that in a perspective, and depending on the kind of analysis we want to do, we may create a contingency table or a matrix format to start analyzing that, and we may create graphs out of that to get some first hand flavor of the data or the information we are seeking from this data. And then this elaborate analysis process starts, and we start applying tools, we start applying some diagnostic tests, indicative tests and confirmatory tests. All these tests are done once the whole process starts, and the idea is that we have basically some questions in the mind, and we want to really find answers to those questions which we confront in a business situation. So later on we will show with the help of the example so that you understand what we are really talking about. And once we have data analyzed, we have the reason to now interpret that. So interpretation essentially requires the domain understanding, because you can have fantastic roles, they can create a lot of outputs, which we have seen in organizations. They have spend a lot of money in getting these kind of applications, and they churn out a lot of reports. But the problem is there has to be the power and competence to analyze the data and interpret that data, because interpretation is something which is basically built on art and skill and the expertise. So once we are able to interpret the data, and then possibly we can really recommend a situation, suggest a particular option, because in any decision situation, the basic crux is that we are basically having multiple options to reach a particular, to resolve a particular problem or seize a particular opportunity. So we have multiple options. So to really find out which is the right option for us, we should be able to interpret the results and arrive at the most optimum or most feasible option across the options available to us. So having said that, once we do that, a good analyst or a good analytical professional is supposed to really reflect on what all has really happened in the process, because that helps us to groom ourselves to develop as a better analyst for the future. And that is what basically is essential in the whole process, is that we should really learn from our mistakes and learn from our inaccuracies. So we should reflect on what did we really learn in the process. Like let's say we conduct a survey, and we have a timeline, we can get the data, we analyze that, we publish reports or we submit reports, whatever we do. But at the end of the day, we may have really done a lot of mistakes in the process, whether it is creating the instrument, or it is administering that questionnaire survey, getting data, talking to the participants, and analyzing, selection of methods. All these stages which happen in the process of the analysis and research may normally have a lot of learning nuggets which happen over there, because we may not do everything perfect in the first go. So we have really learned from our previous experience. So second thing that we should really look at is what conclusions we draw from the analysis we got, the interpretation we made from the analyzed output of the data that we had, and we should be able to really conclude something. If we are not able to conclude, that means there are missing links between what basically is the output and what is the problem, and in between that what are the different concepts that really stand in between that. If we are not able to really capture those or get grip of those, we basically may not be able to conclude properly. We may still keep the whole situation quite vague and weird. So it is quite important that we really develop ourselves in the field of what we call as conclusion making. Conclusion making is a very interesting domain in itself, because it requires a lot of conceptual understanding in the domain we are basically taking decisions. And of course, with conclusions, then we normally make recommendations, whether it is an executive in an organization, or it is an officer in a government department, or it could be somebody in any other setup. The thing is that after we have all these things done, we should be in a position to recommend something, because otherwise the whole effort that we do, there's a scope and there's a purpose. So the whole thing really ends up with making some recommendation to the people who are taking decisions, proposing something to them very constructive, and with the kind of information that would be helpful to them. That maybe, let us take a case of a company who wants to really make profits, and they have multiple options to handle, and they want to select one of the options. And if you are asked to do some number crunching and give some suggestions and recommendations to the management committee like that, you possibly may have some data, some analysis and some recommendation for them. But it's also important, along with that, you give all those areas of risk and concern which could be quite useful when they are trying to agree or disagree on that particular recommendation. What is the amount of risk involved in that particular recommendation? So if that person is ready to take the risk, that they may go ahead with whatever you are proposing. But if they are not ready to go ahead with the risk, they may take option B. So that is what basically is important in the recommendation, that you give the complete truth, not only truth. What basically you think or what is available first hand through the analysis. So more analysis, more information, more truth is always helpful to the decision maker. And also, what are the limitations of the analysis? You also have to really identify that very clearly, and possibly you may really want to tell this thing to the people who are taking decisions. And in case you are taking decisions, then it is of course helpful to you as well to know what were the limitations, because it is always good to really seek say recovery of those limitations in the next time, because maybe we have some decision at hand and we got to take a decision in next 2 or 3 days, and we are very since we are very short of time, we may not have every data in place, and we may not have all possible information with us. We may still analyze, we may get results, we may have we may be more we may be sure to the extent of around 80% that we may be right, but there is a 20% concern and the the area of error tolerance. But the idea is we should be aware about that, how much is the error portion, so that next time when we are meeting a similar situation, we can really buy it more time and give more justice to the whole issue of decision making. So the first thing that we are talking is that we should plan for when we are doing the analysis. The basic question is, why do we really need to plan? The idea is that if we don't plan, we may sometimes have a question and we start getting data, we start analyzing things, and finally end up giving an answer which possibly may be right, but it could be a right answer to a different question. So it is quite important that we align the question and the answers, and that is why we need to really plan, so that our plan is aligned to our question, because we need answer for our question, not the other question which is answered by the whole analysis outcome. So that is one reason that we should really plan. And when we are planning, we really take a lot of precaution, and we a lot of provision for such things which are important for the decision making and for the analysis, like what kind of software we can use, because there could be multiple softwares to use, multiple techniques to be applied, multiple sources of data. And if we plan it well in advance, then we are in a better situation. We can really have the right source of information, right kind of data, right kind of tools, right kind of methods. All these things can fall in place only if we plan it earlier. So that is why we really need to plan. And also that it helps us developing the reliability in our decision making. That is, if we are able to plan better, we can always ensure relatively more consistency in terms of what we really measure, and is this measurement correct across say constituencies, across say different times, different situations. We can really handle that better. We can do pilot testing, retest, whatever we want to do. Is this is only possible if we plan it and if we do it in advance. So what are the different ingredients of a plan? This plan has basically the set of questions, or we say the analysis objectives, or what are the goals of decision making. Once we have those goals in the place, we basically ask certain questions. So in a whether it is a business research situation or is an academic research situation, we start with some questions in the mind. For an academic researcher, that guy could be possibly doing a lot of literature review and trying to develop some questions based on that there's a hunch that A is associated with B because of some previous theory which has been developed by the earlier scientists or academicians. And similarly, there could be a business situation. The CEO of a company or the marketing head of the company could be thinking of some possible association between the kind of product they could be introducing in the market and what kind of response it would have in the market. So they can actually ask that question and try to find answer through a proper analytical process. And once we are able to put our questions accurately and properly, we try to find the evidence either in favor of that or which is not in favor of that, and then we can actually what academicians call, we reject a null hypothesis or we accept a null hypothesis based on how much evidence we have in the favor of alternate hypothesis. That is what we are basically, the question we are asking. We basically lay an hypothesis for that, and null hypothesis that we maintain the status quo, and alternate hypothesis that is that the situation is the otherwise, because there is a lot of evidence in favor of the alternate situation. So having said that, we should also in the plan we should have also the reason for what kind of lessons we got to learn from the whole situation. So once we know what we got to really learn from this, what kind of answers it will really throw out, that helps us to really make much more effective plan. And in case we don't know what kind of lessons, what kind of insight we got to get from there, we are actually wandering around in a particular situation, and we may not have a goal oriented approach in the whole process. We may end up coming something which is not really required for a particular situation. Good in an exploratory situation where we don't have any kind of a goal, but not always feasible to really wander like that. And also that in the plan it is quite important that we figure out what kind of analysis technique we got to use, because techniques vary in terms of the accuracy, in terms of their scope, in terms of what kind of robustness these techniques have, and different techniques need to really have different kind of assumptions in place before you apply that particular technique. So if you are not really sure about that, these assumptions would be met after we get the data, and then possibly that kind of technique may not be really helpful and may not really make any sense. So it is quite important that we are sure about that the technique we are applying, the data and the situation meets the requirements of that particular technique. Same is case with the software tools that we are going to use while applying a particular technique, because tools differ in terms of their kind of data they can handle, amount of data they can handle, the time these tools take in terms of the processing, and the kind of money that you have to really spend if it is a business situation and an organization has to spend to have those kind of tools. So if you are already having certain tools in the organization you are working for, then fine, those are the tools that you can always access. But if these tools are not really available, and if you think that particular tool can really help you taking good decisions on a routine matter, then you got to really consider the cost and the provision your organization has for such kind of tools. So this is quite important that you really understand, appreciate the importance of the analysis technique and the analysis tools that are available while you are making a plan. And finally, the most important thing is that finally all this analysis, everything done, you got to present this data to somebody. So in case of an academic exercise, we possibly have a thesis which comes out, or a dissertation book which comes out. You may publish certain papers, which is basically the presentation part of the whole analysis. But in case it's a business research, you may have to make a presentation to the board, to the steering committee, to your seniors, or your colleagues, or whatever. The thing is, there's a presentation part in the whole process, and that presentation part is the most important part of the whole process, because that is where everything is basically sort of audited, and people whether the whole exercise was worth, and whether we are able to really derive any kind of value from this whole deployment of resource. So presentation is something that we got to really understand is really important, and it should be done in a manner that is easy to understand, that helps the people who look at it understand the situation, understand the process, understand the outcome much better, much easier, so that they can make sense out of it and can really understand the recommendations, how they are related to the whole analysis that you or whosoever has done it, so they can relate that. Now we come to very important part of the whole process is the data, because that is the soul of, that is the raw material which we use to analyze while we are taking decisions. And important thing is that that over a period of time, the amount of data that has generated in the organization is humongous. Some organizations have data which is in terabytes, and much more higher amounts of data get generated in a day. Big retail shops, they have huge data getting generated. Big public sector houses in the public service domain, they have also huge amounts of data getting generated. Think of railways, think of airlines, huge data that is getting generated, which may not be same for an organization which is on a smaller size and is operating in, let us say, B2B situation, may not have really that much of data, amount of data or quantity of data, but some organizations have a lot of data. But important thing, common denominator across both the types of organizations now is that because of the advances in information technology, we don't think there would be any company who doesn't now maintain data. Almost most of the companies, almost even the smaller retailers now have computers. So all these organizations, whether small or big, have data, and that makes sense for really applying data analysis tools and techniques to make use of that kind of data that has been generated and that is getting generated and will be generated in the future. So what is this data actually? And data is something which is which captures an incident, an event, a phenomena, a description, a profile, a transaction, and it can be numeric data, it can be qualitative data, it can be content data, it can be in the form of a visual, it can be form of a sound, it can be any form which has some kind of an interpretation for the user. So all this basically falls in the domain of data. And data, once processed, becomes information. Information was applied, and with the kind of experience we develop, with the kind of information we deploy, then gradually the knowledge gets generated and leads to finally wisdom and highest level of say what we call as the peak of the whole process, from data to the wisdom. So the data, as we are talking about, it could be a quantitative data which is quite numeric kind of data. We have numbers like 1, 2, 3, 4, which is discrete data. We can have decimal fraction data, which is called continuous data, like data about the weight, about say income. These are numeric data, are continuous data. But let us say we want to see how many plants are there in different say geographical areas. This is discrete data, and it cannot be in the decimals because these are simply, they could be only integers. So this is discrete numeric data. And then there is data which helps us to order or categorize levels of psychological constructs, which is called ordinal data, like how tall a person is. It could be dwarf or somewhat taller, very tall. So this is basically, we are trying to order the height of a person, not by the feet or inches, by a qualitative judgment. We are basically making it an ordered data, which is called ordinal data, which becomes qualitative in nature because it doesn't have number. It is just ordering of a particular trait or a characteristic. And then we have another type of data which is called a nominal data, where basically there is no order. It is just an assignment of value to something to understand, to really classify and categorize things. Like we know we have different say districts, we could code them as 1, 2, 3, 4. We have, let us say, 500 districts or 550 districts. We could code them 1, 2, 3, 4 up to 550, but numbers don't mean anything. They are just to really identify the districts, to help us understand or talk about it, or use a language that can help us to communicate with each other better by codifying through a particular number. But essentially there is no importance of number. It cannot be used as an operator. We cannot multiply it, we cannot subtract it, because these are numbers just to identify something. These are called nominal data types. Now, this kind of data is very important, and is we should appreciate that when we are talking about an academic exercise, or we are talking about a marketing research exercise, we are talking about a business research exercise. But there is data also gets generated in organizations who have, let us say, enterprise systems, who have computers, who are running operations or who are running projects. That is data in that particular domain is given the name of what we call as the transaction data. And many companies over a period of time transfer this data into something what they call as a data warehouse. That means data which becomes important and is aggregated and abstracted is put into a different shape and form, which is called data warehouse. The important thing is that then you can access the kind of data with the kind of, say, dimensions quickly, and can analyze it faster. And you can use historical data, you can use current data, but the important thing is that there is more trend towards using lots of data and developing these warehouses and data marts to analyze the historical data along with the current data to make better predictions and more accurate decision making. So this is something regarding the quantitative data. There is another set of data which is actually qualitative data, which is in terms of, say, content, which is text, which is verbal discussions. A lot of data is getting generated in newspapers through various kind of, say, observations, interviews, where there are not numbers, which are basically this is a content. You can't really number anything, but these are really important. They reflect a lot of reality when such data gets generated. So there is another technique in analysis which we call as case study approach, where we go and actually talk to people, interview them, and they say something, they narrate certain things. We need to really analyze that, because that is quite important. If the art and technique of really analyzing that data is becoming very, very important nowadays, because a lot of content and text is now floated online and is available to us, like social networks, etc. So qualitative data analysis becomes quite important. And of course, more and more people are trying to club both qualitative data and quantitative data to collaborate the results, to really arrive at much more concrete say, outcomes. Because if you are able to use both the methods, it reinforces each other, then your belief in the final outcome is better and stronger. And another thing that we need to understand is and appreciate is that as a decision maker, as an analyst, or as a researcher, a good hang of what kind of data sources are there, where should I really put my hands on to get the data, which data is more accurate, identifying that, selecting that. So this is something that is developing as an art and skill nowadays, because a lot of data sources have emerged over a period of time, because people are trying to move to the analytical areas, analytical domains, and people moving there makes a business case for providing information. So a lot of companies are providing a lot of information, but the important thing is to really figure out which company is providing what information, and what information you can really rely on is something that you got to really understand. So data sources, like let us say internationally, if you want to get into any country and want to understand what kind of, say, companies are operating, what are their strengths, how are they doing financially, you may look at the data like Bloomberg, Reuters, etc. Let us say you are in India, you want to understand Indian firms, what are they doing, how are they faring in a particular sector wise. You can do all this, is quite possible, and provided you have the data. And then there are a lot of companies who are providing the data like CMI, Proves, ACE, Accord. There are companies who are basically providing this information. There are plenty. And if you don't have data for, say, when you are doing analysis for, say, social constructs or psychological constructs, you are doing something, some decision making is regarding marketing, you want to launch a new product, you want to find a response to your advertising, etc., then possibly you will go for say syndicated data, or you will gather yourself the data. Syndicated data would mean that companies who are already conducting surveys and developing reports, and they do it sector wise, product wise, category wise. So you can use the data, get the data, and further analyze it in your, say, analysis. You can incorporate that data as well. Or it could be sometimes they could be assigned the complete exercise, but these sessions we are basically trying to look at how you develop an expertise and what is the process you should follow if you have to really analyze that. So what you are supposed to do and what we are supposed to do as analysts, probably those companies who are professionals in this area develop those reports using a particular methodology, and important thing is that we understand how much rigorous those methodologies are while they have created and churned those kind of reports. So syndicated reports, and then possibly if it is not really available, you want to do something in a particular sector, get into particular geography, and there is no such report available, you may have to do something yourself. So in that case, you have to choose what kind of data you want, who will provide you the data, and what kind of instruments you will use to get that data. You may through a survey, you may send people, and or you may send mails, or you may ask people through telephones to provide information based on some instrument, what we call as a questionnaire. Now, questionnaire development is another interesting say aspect of the whole exercise, is how you develop the questionnaire, because the questionnaire is something like an instrument which will measure and extract more all relevant information which is necessary for your decision making. So this art of measuring right thing by right questions and eliminating most of the waste in the whole question answer sequence is something that is that doesn't come all of a sudden. It needs a lot of practice and experience to develop good skills or good questionnaires. Having said that, once you have the data, you understand the sources, then possibly we move to the second stage of data analysis. So when we are analyzing data, first what we do is we normally try to compile the data. We try to put it in place in a perspective so that we understand what it basically indicates, first hand flavor of the data. So we may create contingency tables, we may start getting the descriptives. So the domain of statistics helps a lot in analyzing this data, and that has become very, very common now. Statistics has become like a grammar of the modern day citizenships and survival. So statistics is important in describing the data whatever you have, because it statistics uses parameters to make sense of huge amounts of data. Let us say we have data about say 10,000 people about their income. So rather than learning and remembering everyone's income, we can look at a graph. It can give us some indication of how the whole population looks like in terms of their income status. But if we have descriptives like average, standard deviation, skewness, range, quartiles, it helps us to really quickly through some parameters understand the whole data, which could be thousands or which could be millions. So that is the power of descriptive statistics, which helps us to get actually more deeper into the data through certain parameters, the hook for the whole information. So once we have these descriptives, these are important, as I said, but apart from that, the other part which we said is graphs, the visualization, which is becoming very, very popular, very, very trendy now, what we call as information visualization, that people want to really take analytics to a common man, to a common user, to a common decision maker who doesn't have much understanding of statistics. So they, without understanding statistics, they should be able to interpret, use the data and take decisions. So for that, information visualization is something which helps us to visualize the data through across its dimensions, and helps us to understand the associations, the intricacies within the dimension, so that we understand what dimension is more effective for a particular situation, what dimension is least effective for a particular situation, which dimensions actually interact with each other, so that we are able to handle that situation much better by knowing what dimensions cause what and how they interact with each other. So graphs are very, very important tools for such kind of visualization, and a lot of new tools have developed which helps us to look at the data which is over a period of time, across situations. So you could really do any kind of analysis with these kind of tools which have now come up, and particularly talk of, let us say, social networks. We have data which is about, say, billions of people who are on the network now, social networks, and a lot of this data is available. Companies have put their websites and they have fan clubs. Multinationals like Coca-Cola, Starbucks, they have millions of people who are visiting, who are their fans on the website. Now they would definitely like to analyze this huge data which is available over there, because this data makes a lot of sense. They talk, they interact, they make comments, which is qualitative data. But number of people coming, how many friends they have, what kind of say profiles they have, which is quantitative data. So both quantitative and qualitative data is available in tremendous quantities on the new social networks, and companies are really interested in analyzing data, and makes a lot of sense for them. So having said that, the descriptive analysis with the help of, say, descriptors and the visualizers, we then next come to something what we call as generalization or external validity. That means once we have some conclusion from the data, can we apply the situation for the entire population? Let us say we want to really understand the mood of the population, and mood of our customers, mood of our customer segments towards our new product enhancements, or we have changed the price of the product. Now we want to see beforehand, before we actually do this thing, we change the price or we make some augmentation in the product, how it is going to really affect them. So we will take a sample, we will talk to some customers, and based on that we will take a decision for the entire whole segment. Once we are collecting data, we are actually looking at the sample, which is not the population. So sample is a part of the population. So what we conclude from the sample, which we call a descriptive outcome, if we are able to generalize that for the whole population, then if the same thing stands, that means if I say that the sample which we got is quite happy with the price that we can really charge from the next month, can we really apply it to the whole population? If we are really satisfied about that, then possibly we may execute this kind of a decision in terms of changing the price for our product. But the thing is, how do we really generalize it? What is the process for that? So this is a statistical concept, what we call as sampling distribution, which helps us to connect sample with the population. And in the sample we have, say, point estimates, like we have mean, we have a standard deviation, but when we try to generalize it, we don't have the point estimates. We are trying to look at the complete. We have basically a range that we are talking about, the spread we are talking about. That is, the mean would not remain the same mean, but it would be a kind of a spread range we would be talking about. That would be effective in terms of the reference for our decision making henceforth, if we are generalizing it. So that is important, because ultimately we are not talking about samples, we are talking about the population. So this ability of transforming the sample outcomes for the whole population is something that we got to understand and learn while we are developing ourselves as professionals of analytics or data analysis and research. So now we come to the kind of softwares that are there. So the whole idea of having this session today and sensitizing you about the data analysis with the help of the softwares. So we have this plethora of softwares which are really available. Let us talk a bit about them. So the first software that we are going to really look at is the Excel, which is the most ubiquitous and all prevalent everywhere. All offices, schools, organizations, most of the people somehow have been using Excel at some point or the other, but the amount of Excel they use possibly, I believe, is quite limited. It can do a lot more than that you possibly may have used most of the time. So let us see how we can really use Excel to do analysis of the data that we can have. And another important thing is Excel being the most prominent and popularly available software. A lot of companies who provide data, like we were saying, the sources of information, those companies have actually, data sources have actually integrated their sources with the Excel. That means if you subscribe to a particular data source provider, it will have options that you can call this data into the Excel spreadsheet and can do the analysis. That makes understanding Excel much more interesting than ever before. And also a lot of tools have been added to the Excel. That means the way it was developed initially, the way Microsoft developed it, there were certain features available with the software. But as time progressed, Microsoft also developed certain additional features in the software, understanding the requirement of the decision makers. But there are a lot of other tools which are not provided by Microsoft, which you can add to the Excel and can enhance the power of the analysis and can do much more complicated and advanced analytics on the data you have. So that is something about Excel. We will do some examples with the Excel and see how it can be really helpful in doing modeling and analyzing situations. And then there are other tools which are very, very popular and important, which we need to understand, is which are very helpful in data analysis. Statistical tools like SPSS, quite popular. It was basically very much in the social sciences area and psychology domain. A lot of people use it, and management, it is quite popular. And you can do all kinds of analysis of statistical nature. Though these facilities also available in Excel, but somehow there are limitations. To what extent you can do statistical analysis with the help of Excel? With SPSS, it has definitely a lot of power, and you can do a lot more things. But there is not only SPSS, because being very common and popular in India, there are a lot of other interesting statistical softwares which are quite popular and rather strong and robust, like SAS. SAS is another software which is very common and very popular and very powerful and accurate and is of a very good standard. Similarly, we can use R, we can use Statistical, and you can have Minitab. So these are different softwares which one can use for statistical analysis, and hopefully we will use one of them. We can possibly use SPSS in next few sessions, and see how we can use SPSS to do some data analysis. Then there are simulation tools. Again, as I've been saying, over a period of time, Microsoft has been developing facilities within the Excel itself to address issues of data analysis. Now, in the Excel itself, we can do simulation. And frankly, if you do with Excel, you can really understand what the simulation is all about, because you will be actually developing the complete process and the logic of simulation. But it has again a limitation. If you have to really do simulation of a large scale, and if you are in a big company or a big organization, or you have huge data and want to really do something complicated, then Excel won't really support you. It gets choked up after you have a very huge data or big data, and you are doing many processes within the simulations. So there's a problem with the Excel. So Excel is good for learners, but there are advanced tools available in the market, like we have Crystal Ball, we have Simulate, we have At Risk. So these products, and there are a lot of others, and most of the enterprise services software companies, they've also built in this feature in their products by acquiring such products from the market. Like Crystal Ball has been acquired by Oracle, which was belonging to a particular company called Decision Engineering earlier. At Risk, which is again a very popular software for simulation, belongs to a company called Palisade. So these softwares, if you want to really learn these softwares, these are available for a trial, as a trial product for maybe 15 days to 30 days, and then you can use it. If you find it useful, then you can possibly adapt it in the new company, depending on the budget and provision and the kind of decisions you take. If you think that these decisions are taken quite regularly, possibly yes. Like I would say, if you are a banking company, if you are basically evaluating risk, a simulation makes definitely a lot of sense for such companies. So similarly, then there are optimization tools which are used for the operations, which are used almost everywhere, because most of the time we work within constraints and we have to optimize situations, and there are a lot of tools. Again, if you go to Excel, there is a product which is called Solver, which is meant to optimize linear programming models, or say optimization models. So, but again, it has some limitation. It can't really handle advanced optimization for that. Again, there are a lot of the products in the market which are quite advanced, which you can add to the Excel and do same thing which you could do with the solver, but much more accurately, much more robustly. So like the company which has this product called At Risk, a company called Palisade, they have a product called Risk Optimizer. You can do that, you can use that product. And then there is Evolutionary Solver is another product. So there are a lot of, the idea is not I am recommending a product, but what I am saying is a lot of the products in the market which are much more powerful, which you can add on to the Excel to really do justice to the whole data analysis. Then there are data mining tools. There are a lot of data mining tools available. Of course, this data mining tool you can you possibly have to do with the software only, which is not Excel. So there are few products which are very, very popular in the market in terms of the data mining. There's a product from SPSS. By the way, SPSS, as I say, is not really now, is a product from the IBM, because SPSS has been acquired by IBM. So the product which is meant for the data mining from SPSS is used to be called as the Clementine. Now because it was acquired by IBM, now they call it the Decision Modeler. So they call it Modeler, which is actually Clementine earlier. So it has all the facilities that you can actually mine the data, you can use different models which are available over there to find patterns in the data, hidden patterns in the data, associations in the data, which really throw a lot of surprising and interesting results if you really learn that art. So it is quite interesting. So we will give some more overview on data mining possibly in next few days. There is another product for data mining which is available from SAS. SAS product is called Enterprise Miner, which is very, very powerful and has a lot of features. By the way, we were talking about the social networks, and a lot of content gets developed on social networks, and because there is a lot of content, there is a lot of text, along with the data miners have come another breed of products which are called text miners, and which help us to mine the text which is available in the soft form, and then you can actually analyze that particular text. What basically is the undercurrent in the text? What does it really predict? What our people say? What is the kind of convergence across the opinions? So all this is quite possible with the help of text miners, and these products are also readily available with most of these providers. IBM has it, SAS has it, and so have some others. So that is something interesting about this field of data mining. Then there are business intelligence products like we have Spotfire, and we have Cognos. We have similar other products which actually help us to get more insight and intelligence of the data we have actually in place. It doesn't mine data, but it is based on the concept of that you already have data. It is data in the warehouses, you have data in the huge data getting generated through data transactions, to really report it and and control the whole reporting process. You have these business intelligence tools which can really give you much more broader and defined view of the targeted variables by manipulating and articulating the variables which influence that particular variable. So idea is that business intelligence tools give you much more elaborate and 360-degree information of the variables you are really targeting or you are investigating. So very, very powerful tools, and most of the companies in fact are looking at these kind of tools as something is an essential in the current competitive times and possibly in the future as well. And then there are tools which are now available to analyze data, which we call as the network analysis tool. There are a lot of products in the market, and first what is the network data we are talking about? The network data is people on the social networks, let us say, is very interesting. People who are trading across, say, countries, they are basically on a network. So people are transacting. When people are transacting, they send and receive information, they send and receive material, they send and receive whatever they receive. So they are into a particular network. So there's another approach to the whole analysis is the network analysis. We were trying to look at who are more important in the whole network, who influences who, how to really penetrate a particular network, how to get out of the network. So all these important things that you can really do with the help of these kind of tools which have now come up. So some tools I would say is like you have Gephi, you have Paycheck, you have NetLogo, you have Node Excel, and of course Node Excel is something which is compatible to the Excel. So you can, like I was saying, there are a lot of products which are add-ins for the Excel, so you can use Node Excel kind of a product for network analysis with the help of Excel itself. And then there are a lot of other advanced tools which one could use for data analysis, which are meant for different kind of techniques also. So they are technique specific products, like somebody wants to do very advanced and complicated, say, principal component analysis to analyze and classify data. So there are the product like Visumap and other products. So then there are products which work on, which are more focused on the forecasting. So you have such products also available in the market, which are no specialized products to really handle that. So in nutshell, there are a lot of products, lot of analytical tools available in the market. But also I would like to tell you that because this is something what we call as the web era, a lot of information gets generated on the web. There are a lot of companies now who provide you ready stuff in terms of the data analysis, and you can add your analysis on top of that, or you could use that analysis. So the skill there is to understand the outcome, the metrics that get generated through that whole analytics and the analysis. Like Google Analytics, Google, if you have site, if you want to really analyze the data, Google has a whole set of say analytical say solutions for you to, and it is absolutely free, it is not actually charged. Similarly, Yahoo has its analytical solution. But there are products in the market which analyze data, particularly it is more used by the companies who are using web as the major tool of say marketing or strategy. So they need actually that kind of data for search engine optimization or pulling more traffic to their website. That data is very, very important to them, and they may use these free products, or they may possibly opt for say products which are brought from the market. Like we have HubSpot, which has such kind of say products. Then there are products which are from a company called Adobe. They have a product called Omniture. You can use that product as well for that kind of an analysis. And not only that, there are then a lot of other products which are available in the market to help you to analyze the comparison of how you are doing versus the other company. So they are very quick, they help you to strategize things. So like a company, these services are available online, so you don't have to actually buy the product, you have to actually pay for the service. So this is another interesting thing in the Apple say use of software for the data analysis. A lot of products you don't have to actually buy because affordability becomes an issue sometimes. So you possibly can buy the service, use the software for the period you want, depending on how many users are actually using that particular service, and that is a kind of possibility that is happening. And a lot of people, particularly smaller companies, small individuals who can't really afford higher budgets for that kind of software. So such things are also possible. Now what we are going to do now is move on to the first product that we discussed just now, was the Excel. So we will see how can we use Excel to model a particular problem and do data analysis. We will go step by step from very simplest to the most, then we will move on to the complicated things. And so we will do a bit possibly today, and possibly then we can move on tomorrow and doing a complete exercise with the help of Excel. But certain things that we got to really understand before we really move on to Excel and do a particular exercise and do data analysis, certain important things to remember always when we are using Excel for data analysis. One is that Excel workbook, as we call it, has different worksheets, and workbook has to be treated like a database, and worksheets have to be treated like tables. So people who understand the concept tables in a database, each table should be respected like a table only. You should not mess up everything in one worksheet. So one worksheet should be meant for one kind of say data, and one kind of model, one kind of an application. And second thing is use only references. Don't hard code the data. That means if I am having data which is basically linked together, we should link them through a formula, through a reference, rather than actually typing it out. If any cell later on is isolated, is not referred in the model, in the whole sheet, that means it is a waste over there, it is not used anywhere else. So that is the concept. So it is important that you understand the concept of references. We will actually show you how it is done. Then the most important thing is that doing analysis, the final thing is the data presentation. While you are making it, you have to take care of that. Like we said, you have to plan it early. If you can't really do it from the initial stages, then you can't do it at the end, then it becomes quite complicated and inertia crops up. So it is important that while you are developing your whole analysis process with the help of your Excel or whatever it is, you should use nomenclature, you should use proper names, so that it is understood by you, it is understood by the person who actually sees that information and who sees the outcomes or the reports. So that is quite important. Make it presentable and easy to understand. And easier things, we say concept of parsimony in research or analysis. These the simpler things explain the best thing. So the make it more simple, the best is, but it's not easier. Making things simpler and easier is not at the same time easier. So that is an art that one develops over a period of time. Another thing that is quite important is you have as an analyst, develop somehow this concept of what we call as mathematical thinking. That how can we portray a particular problem in mathematical form, let us say in the spreadsheet. How do we do that? So if we have to write a profit equation, it is easier. But if I say that how do customers react to a particular situation if we change the price, if we change the distribution policy, to putting it mathematically in a spreadsheet is something that we got to understand and is very, very important in the area of analysis. That is psychological and sociological interactions. How do we portray that mathematically? And finally, no model is perfect. Whatever we do, it keeps refining. So idea is, don't get disheartened if your model doesn't give you accurate results in the beginning. It is quite possible that you developed a model, you did some analysis and still results may not really be, and somebody may really fire you at the end that you did this whole analysis, you spent a lot of time and your results, I don't really believe in that, or your results are not really matching with what has really happened. That doesn't mean the concept of analysis is bad. The means that we have to learn a lot, we have to learn from the mistakes. So if we develop a model, it is important that we refine it, we continuously refine it. We see where we went wrong, what data actually made it wrong, so that we can really improve on the data, we can improve on the step, we can improve on the process and make better models next time. So with that thing, you can now start with the Excel. Let us get some initial vocabulary of Excel and move further. So as I was saying is, like, this is a simple Excel sheet, and if you see, this is the workbook and these are the sheets over here. I have slightly magnified this. I think this is visible. And if we have, let us say, we start with some basic equation. We have sales quantity, we can have price here. These are don't take it so seriously, this is just to explain certain things, and I say profit. Very simplest equation we can have, and we can say, let us say sales quantity is 1000, price is 10, variable cost is 7, then what is the profit? Now here I am using a reference, I am using a formula. This is important, that is sales quantity multiplied by price minus variable cost, and I put it here. Okay. Now this is one way of really doing it, is that I have actually created a reference over here. Now people who don't use references, sorry, what they do? Just a minute. Yeah. So they will simply type it 3000. They may actually mentally calculate this whole thing and type it over here. That is called a hard coding. But the way we have done it is referencing. But still it is not the right way. What I have done is, this portion is data, if you see it. This is data portion. And what is the model portion? This one is the model portion. This is the model. That is, model is the profit model. So ideally I should put profit somewhere else in the second worksheet, and I should put data in the worksheet number 1. Then rather than putting it here, we should put it somewhere else. So I think our time is just we are over with the time. We will start from here tomorrow onwards and take it from here. Thank you very much.
Okay, so we will discuss model part and other things which are required for the data analysis and all this in tomorrow lectures.
Yeah, sure.
Using this Excel tools and SPSS. Okay. So, well, friends, with this word, we conclude the lecture. And I thank all of you for watching the lecture. And on your behalf, I thank Dr. O.P. Wali for giving such an insightful lecture on this topic. Thank you very much.
Thank you.